Aging. It's something that happens to everyone. Every day we are alive, we age. From the day we are born, we're constantly changing. Whether it's from a crying newborn to a toddler taking their first steps, or from a fun-loving child to a moody teenager, our bodies are always changing. But when we're talking about aging here, we mean the aging that happens rather towards the end of one's life. But what exactly is aging? We like this definition by Aubrey de Grey, one of the most prominent figures in aging research nowadays. Aging is a set of processes that progressively reduces the time before the individual is likely to suffer a permanent loss of physical or mental capacity. Aging comes in many shapes and colors, but what usually comes to mind when we think about getting older is wrinkly skin, vision impairment, hearing loss, fatigue, memory loss, high blood pressure, and other age-related illnesses. But biologically speaking, what exactly happens to our cells that causes us to age? Although aging is caused by complex multidimensional pathways, put simply, cell division isn't perfect. And every time our cells divide, a bit of the end of our chromosomes gets lost. To prevent crucial DNA getting lost, the ends of our chromosomes have little add-ons called telomeres, which are tandem repeats of DNA that do not code for any genes. But after each division, those telomeres get shorter, and at one point they are lost completely, after which the cell stops dividing. But rather than just dying, the cell becomes senescent. When a cell becomes senescent, its characteristics change too. It can no longer divide, it starts expressing different genes, and even negatively affects surrounding cells. So, as we age, these senescent cells start building up, and our tissues in turn become worse at regenerating themselves. So, what is our project's approach to aging? Well, we're looking at a few different aspects of aging. Here we'll discuss a little bit of each. Lycopene is a chemical naturally found in tomatoes and is known to be lacking in the elderly population, so we want to have an oxidative stress-induced biobrick, which then in turn releases lycopene to clean up these reactive oxygen species. Now, our second project is based around dental health. In particular, we're developing an anti-plaque bacteriocin. At later stages in life, dental health gradually declines as it becomes harder to maintain a good oral health and the oral environment changes, making the environment more hostile for good bacteria, allowing bad bacteria such as Streptococcus mutans, which is the bacteria that produces plaque, to thrive. So we're using one of the bacteria found in everyone's mouth to produce a bacteriocin which can kill off the evil plaque-producing bacteria and hopefully improve overall oral health. Another issue that many people may not be aware of is that in recent years the rate of STIs has rapidly increased within elderly populations, especially within care homes. This is due to the fact that back in the day less attention was paid to such issues, and with medications now available to counter erectile dysfunction and ample time on hand, the elderly become quite active. So, our idea is to create a biosensor within lube that changes color when it comes into contact with an STI, allowing for quick and effective detection of pathogens. This lube can then not only help the elderly lead a more pleasurable sex life, but also a much safer one. The final project we're currently working on is all about pest control using aging. Parasitic wasps have been an increasing problem for farmers as they eat all their crops, leaving it unfit for later sale. So we thought we could use RNA interference in crops to mute a gene called vitellogenin. Vitellogenin regulates oxidative stress in these parasitic wasps, which, as mentioned before, is one of the factors affecting aging. So by muting this gene, the oxidative stress in the body of the parasite will increase and basically aging it faster and thus killing it off more quickly. Thank you very much for watching this video, and if you would like to learn more, please do visit the following links.